So started recording. Let me start sharing that Excel file again. Okay, as I mentioned, two subtopics left for us for today. And those are different types of rates. Okay, this is going to be quite interesting. I like this subtopic. Let me give you one example of two choices of investments. Choice A, okay, your investment, let me even zoom in a little. Oh, okay, your investment grows once a month at the rate of, let's say, 1%. Okay. And choice B, your investment grows once a year at the rate of, say, 12.6%. 12.6%. Okay? So let me go back to chat over here and type the question. Look at the choice A and B of investments and type here which choice you would choose. Okay, guys? So tell me your answers. Which of these two would you choose? Choose choice A for your investment to grow once a month at 1% every year. Oh, I'm sorry, at 1% every month. Every month, 1%. Or do you choose a different investment, choice B, where your investment is only growing once a year? So the new calculation of the new value of your investment only happens once a year, but it's growing at 12.6%. Okay? Which rate would you guys choose? Go back to that chat. Go back to that chat over here. Please type your option. Just A or B. A or B. Many of you guys, I guess, are going to choose A. Many of you guys are going to choose B. Just type your answers. B. Interesting. A few guys of you are choosing B. Let's see. So far, no choices for A. Interesting. But I would have thought some of you would choose A because in choice A, within 1 year, you will have a lot of chance to earn interest on interest. Whereas in choice B, within 1 year, there is no chance to earn interest on interest, right? So it's hard to compare these two numbers, right? Which shows us the difference between different types of rates, okay? So to compare the rates, let me see how much exactly I'm going to earn in 1 year with choice A, okay? So the amount I'm going to earn is, of course, going to be 1.01, right, into the power of 12 within a year, right, and then minus 1. So that's actually, if I convert that to percentages, where's percentages here, that's actually 12.68% rather than 12.6% for choice B, which is only growing once a year at this 12.6%, right? So you see the difference here? Choice A has more chance to give you interest on interest. So even though it looks like it's smaller than 12.6% because 1% multiplied by 12 is only 12, it's actually going to give you better investment option, 12.68% rather than 12.6%, right? So here's an example that emphasizes, that shows clearly the difference between interest rates, okay? So if you just simply take 1% and multiply by 12, so just take this 1%, multiply it by 12, what you get is 12%. And this kind of calculation has a name. It's called annual percentage rate or annual percentage yield. Different textbooks give you different name, okay? So annual percentage rate or yield, remember yield is another word for rate as well, for interest rate, right? Is simply multiplication of rate per period times number of periods in a year, right? But it doesn't always show the actual return, the actual profit you're going to get from the investment. Like in our choice A example, you're actually going to earn 12.68% effectively in reality, although the APR is only 12%. The APR for choice B is 12.6%. So it looks like choice B is better because APR is better. But instead of looking at APR, for the actual amount that you're going to earn, for the effective amount you're going to earn, we need to look at the actual money, right? So there's that other kind of interest rate, which is called effective annual rate. So easy to remember from the word, from the name of it. Which is the actual rate you are earning, and effective is just another word for actual, so it's easy to remember. The effective rate you are earning based on interest, and it's also per year, so it's effective annual rate. You are earning per year based on interest, right? So the formula for EAR is kind of, as you see, kind of tricky. We have this formula over here. It's 1 plus that rate per period into the power of number of periods in a year minus 1. But it's okay, you don't have to remember that formula. Okay, we have Excel for us, so it's going to help us. So let's have a look at this example. Let's say choice C. Oh, and the standard for the industry convention that we have mentioned over the last 1 or 2 hours is the APR, APY. Okay, and let's turn it into red, and this is the industry standard, because it's kind of easy to understand this one, and to avoid any kind of confusion. In most countries of the world, whenever the banks or the credit card companies or any kind of other investment companies advertise any rates, they must advertise APR or they must advertise APY, not any kind of other rates. Okay, so there it is. So let's say we have an advertisement for 2 more investment choices. Choice C, okay, APR of let's say 15.8% with quarterly compounding, okay, which means the investment is growing every quarter, okay. And choice D, APR of, let's say, only 13.8% with daily, oh my god, compounding, oh my god, daily compounding. Which option would you choose? To answer this question, you don't just simply compare APR or APY, because they're on different compounding. One is quarterly, one is daily. You actually need to compare effective annual rate. That's going to actually show you the effective amount of money that choice C or choice B is going to profit for you. Okay, so let's calculate effective rates from these examples. And the Excel formula here is equals effect, very easy. Equals effect, open the brackets, and what do we see? The nominal rate. For Excel, the nominal rate is the APR. That's what Excel calls the APR. APY, APR in Excel is called nominal rate. Okay, so that's just 0.158, comma, and NPRY. NPERY is not NPR. Over here we had NPR. NPR is number of periods in your whole investment life, right? But NPRY, it's a bit different. There is one extra Y over here. That means how many periods are inside 1 year only. How many periods are inside 1 year only. So if you look at quarterly periods, there are 4 periods in 1 year. So choice C gives you an effective annual rate of 16.76%. How about choice D? So again, equals effect, open the brackets, and nominal is 13.8, so 0.138. Here we have daily compounding. So NPRY in 1 year, how many days? 365. Close the brackets, hit enter. Well, yeah, here choice D is still smaller. Let me change the numbers a little bit to make it kind of more of an illustrative example. Okay, let's change it to 14%. And we're going to change this to 14%. So again, it's a better example because it looks like choice C is better. It's going to give me 14% versus 13.8% APR as advertised. Because remember, industry standard in any kind of advertisements is APR, right? But if you look at the actual effective rate, because choice D gives you more chance of interest on interest, it's going to give you more effective annual rate of 14.795% rather than 14.75%. Okay, so that's the Excel formula to calculate effective rate equals effect. NPRY is number of periods inside 1 year only. Okay, so let's type it out so it's clear. NPERY is not the same as NPR. Okay, NPRY is the number of periods in a year. Okay, in a year. And let's have a look at another example so that we learn how to calculate APR using Excel formulas. Okay. An investment with monthly compounding pays, let's say 1.2% per month. How much is APR? Okay, that's one example. Second example is you would like to earn an effective annual rate of, let's say, 15%. How much APR you should look for in investment advertisements with, let's say, monthly compounding. Okay. So first question is really easy. Per month, you get 1.2%. To calculate APR, scroll up a little, we simply multiply by the number of periods in a year. Okay, if you already know the interest rate per small period, just multiply it by the number of these small periods in a year to find APR. So the answer to the first question, right, is simply 1.2% times 12, which gives you equals 0012 times 12, 14.4% APR, annual percentage rate. Okay, in the second example, I don't know the actual rate per month. I just know that I really want to earn 15% per year in reality, effectively. But if I look for some sort of investment advertisements, they're not going to show a effective annual rate, they're going to show APR. So what's that APR I should target in my search? Let's see, answer is going to be equals nominal. Okay, so Excel calls APR nominal, equals nominal, open the brackets. Effective rate of 15, and I'm looking at monthly compounding, so that's NPRY of 12. So any advertisement of 15.06% with monthly compounding will actually earn me, in reality, 15% per year. Okay? So that's the subtopic of the different types of rates. The two types of rates we learned are APR or APY and the EAR, effective annual rate. Okay? So we have only one more subtopic left for today. Before we move on, any questions so far?
So ER is always bigger than APR?
Oh, that's a good question. Let's go back. Let's go back to Excel. Oh, can you please type your question in the chat as well, so I might have a printed form of your question as well, okay? Go back to Excel. So, good question. So the question is, if you didn't hear the question, is effective annual rate always bigger than annual percentage rate? Almost always. The only time, okay, EAR is almost always bigger than APR for the same investment. The only time when EAR equals APR is when the compounding is annual. Okay? So when the compounding is annual, when the investment only grows one time per year, okay, the effective annual rate doesn't have any chance to give you interest on interest inside within 1 year. So in that case, EAR is going to be equal to APR. But EAR is never smaller than APR. So EAR is never smaller than APR. EAR is either bigger or equal to APR. Okay. So let's have a look at an example. Let's say annual compounding. APR is say 8.9%. How much is effective annual rate? So equals effect, open the brackets. The nominal rate is 0.089, and there is only one period within 1 year. So it's annual compounding. As you see, effective annual rate is the same as APR. That's the only time when they are the same. In any other times when compounding is less than per year, effective annual rate is going to be bigger than APR. It's never smaller than APR. Okay. Any other questions about this subtopic before we move on to the next one, last one? Okay, let's move on. Our last subtopic is loan amortization table. Okay, this is kind of tedious, quite detailed, but I hope I managed to explain it clearly. Okay, so loan amortization table is a big table that shows you how you progress with repaying the loan. Let's have a look at an example. Say you borrow 5 million from a bank to buy an apartment, right? Say the bank charges you, let's say 3.6%. I don't say anything about the rates, so that's APR, okay? Your mortgage repayments are monthly, okay? And you borrow for, let's say, 15 years, okay? Let's have a couple of questions here. This table is going to be huge. That's 15 times 12. That's many rows. let's say you just borrow for 5 years, okay? Make a loan amortization table, and how much you still owe to the bank after, let's say, 3 years. These two questions. So let's make a table. What does the table consist of? It starts with the beginning balance. It goes on to the regular payments. Let's look at interest, then regular payments, and ending balance. There it is. And we have periods over here. So the first month and second month and third month and fourth month. How many months do we have? 12 times 5 is 60. Oh my god, it's going to be a big table. Let's zoom out a little bit. We can still manage. The computer is going to do a lot of calculations for us, so that's fine. 60. 60 is too far. Let's make it a smaller loan over a shorter period of time. Let's say you borrow just 2 million. And let's say you borrow for only 3 years. So 3 times 12 is going to be 36 lines. That's kind of a little bit better. Okay. There. So at the beginning of the first month, right, how much do you owe to the bank? At the beginning of the very first month, that's the time where you got the 2 million. So the starting amount over here. Okay. During the first month, how much is the interest that the bank is going to charge you? Well, they're going to charge you 3.6% per year. So per month it's going to be divided by 12 times the amount of money. Okay, so the interest that accumulates on top of what you owe to the bank by the end of the first month is going to be 6,000 extra. Okay, now how about the PMT? We need to calculate equals PMT. That's your regular payments to repay the mortgage in 3 years. So that equals PMT, open the brackets. The rate is 0036 divided by 12. Number of periods is you're going to pay it in 3 years times 12 because we need to match everything to the smallest period, which is a month. The PV right now you're gonna get 2 million from the bank. That's a positive number. You're gonna get it right now, right? And FV by the end of 36 months, once you finish with your regular payments, is there going to be anything else to pay to the bank? Hopefully not. So FV is going to be 0. Okay. Ignore the type, it's a regular annuity because you're going to pay at the end of every month. There, you're going to pay a PMT of over 58,000 every month. Let me make it negative. So negative kills the number, the negative here. I just want to have everything positive in this table. It's easier to work with numbers then for me. An ending balance. So at the beginning of the first month, which is the day you get the 2 million from the bank, you owe the bank 2 million. Over the next 4 weeks, over the next month, some interest accumulates, another 6,000. So by the end of the first month, you owe the bank 2 million and 6,000. But on the last day of the month, you're going to pay the bank more than 58,000. So you're going to owe less to the bank by the end of the first month, right? So this is going to be the original amount that you owe to the bank at the beginning of this period, plus the interest that accumulates during this period, minus what you pay to the bank at the end of this period. Bum. What is this? I already told you, when you see something like this on the computer, it's not a big deal. It means there is no space to show the number. Just give it a bit more space. You will owe to the bank 1,947,000. You will owe to the bank more than 1,947,000. Okay, so that's the last day of the first month. On the first day of the second month, how much do you owe to the bank? Well, it's the same. The last day of the first month is more or less the same as the first day of the next month. So I just hit equals and this amount, enter. Okay, this is what we need to do for the amortization table. The rest is just calculated by the computer. Okay, double click here, then select these and double click. Something is working here. Something is wrong because, as you know, by the end of the loan life, I should owe nothing to the bank. So if you've done the calculations correctly, you can automatically check your calculations. This ending balance by the end of the last month should be 0. You don't owe anything else to the bank. So let's see what's happening here. Okay. So this amount over here should keep decreasing, but it doesn't. The reason it doesn't decrease is because when I copied it, I selected both of these cells and double clicked. So as you see, 2 million, 2 million and 1, 2 million and 2, the computer automatically adds 1 every time. So, okay, instead we should select one cell and double click here. It's zeros for now, no problem. Just select these 3 cells and double click. Bam! Everything is working, I think. There. Yes, it's 0. Now everything is correct. So even if this table is really big for 15 years, that's still fine. You just need to fill out the first period and the beginning balance of the second period. Okay. So this is the first task completed. We've done the amortization table. Now the second task is how much you still owe to the bank at the end of 3 years. Let's change this question because the loan life is 3 years and how much you owe to the bank at the end of 3 years. Of course, you owe him 0. So let's change the question at the end of 2 years. 2 years is 24 months. So at the end of month 24, at the end, you still owe to the bank $690,779.1. Okay, so the answer here equals the ending balance after 24 months. Enter. That's the answer. So that's how we create amortization tables, and that's how we answer questions about this amortization table. Okay. For example, another question could be, how much is the interest that accumulates during the 8th month of the loan, right? Well, 8 months, the interest that accumulates is extra $4,883.44. So the answer here is equal. 8 months interest during that time, over here, enter. Okay, so this is the last subtopic for today's chapter. Remember, back on Moodle, you still have your practice test for today. It's not ready on Moodle yet. I will post the test over the next 20 minutes or so. Right? Let's get back to our Google meeting. And any questions?
Could you please upload the Excel file?
Yep, I'll upload it now, just after finishing this class.
Yeah, thank you.
Any questions?
Teacher, how about the video?
How about the video? Yes, so we have 3 videos. Videos usually big file size, right? For example, a picture is only, let's say, 2 megabytes. A video is like how many megabytes? So it's going to take a while for the video to upload. Perhaps sometime this afternoon. Okay, so I'm going to put it on Moodle late afternoon.
Okay, thank you.
Any other questions? Can you please type your question about the video upload in this chat as well, okay? Because that's going to help me with the report at the end of the semester. Okay? I can't read the Chinese name, but your question about uploading the video to Moodle, can you please type it in the chat, okay?
Yeah, and I have already typed in.
Okay, cool, thanks. Any other questions for today? Thank you, and bye-bye.